All right, guys. So today we're going to do our last lesson of Chapter 7. This is 7.5. So far, it's been all about exponent rules. Today, we're going to look at how to simplify radical expressions. So, what do we know about radicals? I don't really know how to put this in a concise way, but basically, if I look at here's an example of a radical, the cube root of 64. So what is that asking me about? So if it wants to know the cube root of 64, that's really asking me what number, we'll call it x raised to the third power equals 64. Okay, that's what it's asking me. And whatever x is, that's what that radical is equal to. Does anybody know what that would be? 4, right? 4 raised to the third power would be 64. So that's kind of what a radical means, right? So it does have to do with exponents and stuff. It's just kind of the reverse of an exponent or the inverse of an exponent. Okay, that kind of thing. So simplifying non-perfect squares, and then we'll get started. Actually, we'll just ignore that and get started. So first, 12 perfect squares. So these are numbers that are perfect squares. If we take their square root, then that's just going to be like an integer, a whole number. Okay. So 1 squared is 1, 2 squared is 4, 3 squared is 9, then 16, 25, 36, 49, 64, 81, 100, 121, and 144. I'll give you a minute to get caught up there. Those are your first 12 perfect squares. If you're looking at a multiplication chart, it's the numbers that go down the middle diagonal. Okay. So there's 1 in the back. If you can see those numbers, those are perfect squares. Okay. So numbers like these, if we take their square root, it's going to be a whole number. Okay. All right, so let's go ahead and is everybody with me? Everybody good? All right, let's go ahead and look at section 2 here, which is going to be square roots of perfect squares. All right, so number 1, square root of 81. Anybody know what that is? 9. Very good. So we could go back up to our list there if we wanted, and we could see, okay, 81 is the 1, 2, 3, 4, 5, 6, 7, 8, 9th one, right? So that's equal to 9 squared. 484 is a little bit bigger. If you know how to type in the square root of 484, go ahead and do that. If you don't, maybe write down this note. So in your calculator, you hit second, and then x squared. That should bring up your radical. Then type in whatever your number is. So in this case, your radicand is 484, and then just hit equals. Okay. Does anybody have a number? What is the square root of 484? It's probably 1 for the calculator. Anybody type it in? What is it? 22 is correct. Very good. All right. Number 4, you would read that 18 square roots of 4. What it literally means is 18 times the square root of 4, right? So more simply put, it's equal to 18 times 2, which is 36. 256 is a little bigger, square root of 256, so I might type that in. So second x squared, 256 is 16. So this 3 square roots of 256 is really equal to 3 times 16, which is 48. 48. Okay, and then your fractions, and then I'll have you try 3. Fractions are square root. Sorry, a fraction under a square root you can think of this way. This would be equal to the square root of 1 divided by the square root of 16. Square root of 1 is 1. Square root of 16 is 4. So 1/4. And then number 8, square root of 9 divided by square root of 100. Who can tell me what my denominator, or sorry, my numerator is? What's the square root of 9? Yes, Gwen. 3, very good. And what about my denominator? What would that be? Zach? 10. 3 over 10. Very good. So these are all kind of simplifying perfect squares. You guys go ahead and try 3, 6, and 9. I'll go over it in 1 minute. Yes. You hit second and then x squared. Yeah. I know. We're gonna look at a different way to write those. So yeah. All right, so you're getting what you can get down on 3, 6, and 9. I'll go over the answers, and then if you want to see any of them worked out, hopefully you'll ask. All right, number 3 would be 8. Number 6, negative 55. Number 9, 5 over 7. Anyone have any questions? Okay, let's keep moving. Now, that's all kind of basic stuff. It gets tough in this section, so I'll do several examples. There's nothing different between the examples and what these notes are called station 3 or station 4. Same types of things there, right? So, you know, if I type in the square root of 24, I'm going to get what we call an irrational number, okay? Because 24 is not a perfect square. So I don't want you to just punch that in and round that decimal, okay? There's a way to simplify these radicals, and that's the main thing that we're going to do today, okay? I'm going to show you a method that uses prime factorization. So you might remember factor trees from some point in pre-algebra, but if not, we will go over those now. So we want to basically break down 24 into the factors that multiply to 24. And the easiest way to get that is a factor tree. So I'm going to go down here and say I'm going to divide by 2. If 2 goes into a number, that's a prime number you always want to start with, right? 2 goes into 24 12 times. Or 2 times 12 equals 24, okay? 12 is not prime. It's still even, so we take another 2 out. 2 times 6, okay? And then 6, again, is even, so take as many 2s as you can. That would be 2 times 3. 3 is a prime number, so we know we're done at this point, okay? So 24 is equal to 2 to the 3rd power, okay? Read my factor tree. 2 to the 3rd power because we have 1, 2, 3 2s times 3, okay? 2 to the 3rd power times 3. Now, when I show my work under here, I'm going to write 2 to the 3rd power in kind of a weird way, okay? Stay with me, though. So 2 to the 2nd power times 2 times 3. Now, why would I have broken up 2 to the 3rd power this way? Basically, it boils down to this. Anything that has an even exponent on it is a perfect square, okay? So the square root of 2 squared is 2, okay? So my final answer here would be 2 times the square root of 2 times 3. What's that simplified? 2 times 3. Anybody? 6. So 2 times the square root of 6, or 2 square root of 6. If your head is spinning after that, you're not the only one. Okay, just try to get it through reps and stay with me if you want to do the practice. All right, number 11, square root of 48. I'm going to get my factor tree. See what my prime factors of 48 are. So obviously it's even. So 2 times 24. 24 is still even. That'd be 2 times 12. 12 is still even. 2 times 6. And okay, move that. Sorry. And then 6 is 2 times 3. You guys are talking about what's the answer going to be. I love that. Okay, love that. Love you thinking ahead. So there are 4 2's, 2 to the 4th power. I'm going to write that as 2 squared times 2 squared, because those are 2 perfect squares. And then we have times 3. So what comes out? The 2 squares, right? So what would come out would be 2 times 2 times radical 3. And then, of course, we could simplify 2 times 2 to be 4. So final answer, 4 square roots of 3. All right, let's do 13 and 14, and then you'll try a couple. All right, so 13's prime factors, or 63's prime factors would go as follows. 63 is the first one that's not even, so if we divide by 2, that's not going to get us anywhere. Next number you always try is 3. So 63 divided by 3. How you doing? Good. This class gets a lot of notes, doesn't it? There you go, buddy. All right, so 3 and 21. 3 and 21. And then 21 would be 3 and 7. Okay, so 63 is equal to 3 squared times 7. Now that I've shown what to do a couple times from here, I'm going to leave that there. See if you can simplify from there. So what times the square root of what? And again, if you have no idea, you're not the only one. Just hang out for a second. All right, goes like this. Square root of 3 squared is 3. 7's not a perfect square, so it stays under. So 3 square roots of 7. Okay. Let's do 14 and then let you guys have a try. All right, go ahead and factor out 90. I'm going to do so quietly, and then we'll see if we agree. See if we have the same factors. All right, those of you who are done looking at what my equivalency for 90 is using prime numbers, you have 2 times 3 times 3 times 5. Okay, or 2 times 3 squared times 5. So square root of all that, 2 times 3 squared times 5. So what comes out of the radical? The 3 squared, or the 3, I guess. So 3 times the square root of 2 times 5 is 10. 3 radical 10. All right, what I want you to try to do is 15 and 18. If you have more time, just try to do a couple more. I will go over at least 15 and 18 when that timer goes off. And again, I would encourage you, work with folks around you. There's a lot of collective knowledge in this room. You got to use that to your benefit. All right, guys, let's look at those two, and then if anybody wants to see any of the others, hopefully you'll let me know. All right, square root of 175. So 175 is equal to 5 times, let's see, 35. 5 times 35. Okay, 35 is not prime because 5 goes into it. And then be 5 times 7. So altogether, 175 is 5 times 7 squared. So 7 squared times 5. 7 comes out, so 7 square roots of 5. So, what'd I do? Sorry. Oh, yeah, 5 times 7, sorry. Yes, thank you. Sorry. Yeah, I wrote that funky looking 5 there. Yeah, it'd be 5 squared times 7. Sorry about that. Thank you guys for catching my mistake. Good job. So yeah, that was, to correct that, that's 5 squared times 7, which would change our answer to 5 square roots of 7. All right. And then one more. And then I can show the other two if you want, or we can just move on to Alex, okay? All right, so 343 is a number you probably needed to use a calculator on, I would say. 2 obviously doesn't go into 343. 3 doesn't. 5 doesn't, right? It takes all the way to 7 till you get a common factor, right? So sometimes you got to do some guess and check on your calculator. Just start dividing the number by other numbers. But 7 times 49, and then 49 is 7 times 7. So 7 to the 3rd power. Or you could say 7 squared times 7, right? So that would be square root of 7 squared is 7. Other 7 stays under. Here's my last point, okay? Because this can be tricky. If you're totally lost, you're not the only one. Don't get discouraged. Just keep trying. You'll get it. You'll get it through repetition. But if you do get it, it's probably worth your time to like check your answer. Here's how you can do that, because you're only going to have 1 or 2 of these max on the test. But let's say we think the answer, the simplified radical for 18 is 7 square roots of 7. Here's what you can do. You can type it in as square root of 343, so the way the problem was written. And you can see that it's 18.52 and some change, right? Then you can type it in the other way, the simplified way, 7 times the square root of 7, and see if it's the exact same decimal. It is, so we can feel good about our answer there. I'm going to go ahead and cut this video off here. So I'll post an Alex as well. And I think you guys should take about a 2.5 minute break. So why don't you do that? Get up, move around for a minute.